Okay, welcome back. Today we're going to be looking at writing a function rule. This is section 4.5, so hopefully by the end of the lesson you can say I can write an equation that represents functions. So the main thing we're going to look at today is just a number of examples of what we're doing. So for instance, this one, the directions say write a function rule that represents each sentence. So it says 5 less than 1/4 of x is y. So we've done the one similar to this. So 5 less, that means I'm going to be subtracting 5. And we're going to be subtracting 5 from 1/4 of an x. So 1/4 x minus 5 is, which means equals y. So some words you might want to be aware of. Is, when we're writing these, means equals. Of means times. Okay, so P is 9 more than 1/2 of Q. P is 9 more than 1/2 of Q. So P equals 9 more than means I'm going to add on 9 to 1/2 of Q. Number 5 says 1.5 more than the quotient of A and 4 is B. So 1.5 more than, so that means I'm going to add on 1.5 more than the quotient of A and 4. So A divided by 4 plus 1.5 is B. Okay. Next one says write a function rule that represents the situation. So the price P of a large cheese pizza is $7.95 plus 75 cents for each topping T on the pizza. So the price is $7.95 plus 75 cents for every topping. So $7.95 plus 0.75 T. Number 6 says Jacqueline's earnings M are a function of the number of lawns she mows at a rate of $12 per lawn. So the earnings, the money she makes, is a function of the number of lawns she mows at a rate of $12 per lawn. So if you take 12 times the number of lawns, which we are calling N. So 12N would tell you how much money she's going to make. Next one, number 7 says total fees of a book club membership are $10 per month and a one-time fee, administration fee of $4.75. So the fees are equal to $10 per month, so 10 times M, and an administration fee of, or administrative fee of $4.75. So plus $4.75 would be your equation. Next one says Eric is 2 years younger than 2 times his sister's age. Write a rule that represents Eric's age as a function of his sister's age. So that's the first thing we have to do. So Eric's age is A, is 2 years younger than twice his sister's age. So twice his sister's age, 2 times his sister's age, and his sister's age is S, so 2S, and then 2 years younger than that. And then we want, so this would be the function rule that represents Eric's age, but now I want to find out Eric's age when his sister is 11. So I take 2 times an 11 minus 2. So it'd be 22 minus 2, which would give us a 20. So Eric's age is 2 years younger than twice his sister's age. Twice his sister's age would be a 22 minus 2 would be 20. So Eric's age is 20 when his sister is 11. An online music club charges $5.75 for a first music download and $2 for each additional download per month. Write a rule for describing the total monthly fees F as a function of the additional downloads. So total cost would be equal to $5.75 per month plus $2 for each additional download. So $2 for each download. So there would be your function rule. If I want to know if I download 15 songs, how would I figure it out? Well, total cost would be equal to $5.75 plus $2 times 15. So I know that this is going to be 30. So $5.75 plus the 30 would give us $35.75 for the total fees. Next one. Write a function rule for the area of a rectangle whose length is 6 more than its width. What is the area of a rectangle when its width is 12 feet? So, area of a rectangle. I know I'm going to have to do this. Length times the width. So, the first part says the length is 6 more than its width. So 6 more than its width. That'd be its width plus 6. So, what am I going to do? I'm going to now say that the area is equal to the length, but in place of the length, I'm going to plug in W plus 6. So I'm going to W plus a 6 times the W. So we want to know what the area, so this would be a function rule, one way to write it. Another way to write it would be to distribute, so it would be W squared plus 6W would be another way to write it. Now we want to know when the area, what's the area of the rectangle if the width is 6, or excuse me, 12. So if we plug in a 12 for the W, I'd have A is equal to 12 plus 6 times 12. Or on the other one, it would say 12 squared plus 6 times 12. So if I did the top one, I would have 18 times 12, and 18 times 12 is, let me grab a calculator, my brain doesn't want to work today. 18 times 12 is 216. If I do the other one, I'd have 144 plus 72, which is again 116. So the area of the rectangle is 116 square feet. Okay. Next one, write a function rule for the area. So I want you to try and come up with the equation on this one. Pause the video, and then we'll take a look at it together. Okay, so again, area is equal to length times width. It tells us this time that the length is equal to 7 more than 3 times the width. 7 more than 3 times the width. 3 times the width, 7 more than that. So if I plug that back in for the L, my new equation would be 3W plus 7 times a W. So if I use that one, I'd plug in a 3 then, and it would say 3 times the 3 plus 7 times 3. So I'd have a 9 plus 7, which is 16. 16 times 3 is 48. 48 square meters. Now, if I distributed first, I would have A equals 3W squared plus 7W. And then if I put in my 3, let's see if we get the same thing. So I've got 3 squared, so I got 3 times a 9, which is 27, plus 21 is 48. So yes, 48 square meters. This one, very similar. I'll let you try and figure that one out on your own. If you have questions, you can bring it back to class. And then the last one, is the graph of a function that relates to squares side length to perimeter continuous or discrete? Side length compared to perimeter. Side length, perimeter. So if you remember, oh, that's horrible, perimeter. So now, if you remember our conversations about discrete versus continuous, a discrete one would look like, excuse me, a continuous one would look like that. Discrete would be a series of dots. So hopefully we can see that this would be an example of a continuous function. Okay, that's all I have for you tonight. So that is a wrap. You have a great day.